solve these things by substitution, how to solve them by elimination, and how to figure out which is the easiest and best method to use, okay? All right. Systems activity, page 38. Problem number 1 says 2y minus 4 equals 0, x plus 2y equals 5. What are the 3 methods that we have talked about that we can solve equations by when you're talking about a system of equations? One method would be graphing, good. Substitution, and what's the other one I just said not too long ago? Elimination or linear combination. Yes, those are the 3 methods. So number 1 says solve by the any method. The any method? I'm not familiar with the any method. Are you familiar with the any method? Isn't that a knee slapper? No. All right, so take a look at this system of equations. 2y minus 4 equals 0, x plus 2y equals 5. There is no graph here, and graphing probably wouldn't be the best way anyway. What are you thinking? Would you do substitution or elimination here? And why? What?
I wasn't really talking before.
Oh.
I figured it out, but I don't know which one it is.
Well,
Whatever one it is, we'll solve the first equation and then substitute that into the second one.
so that would be substitution. So you solved for y? You isolated y, solved for y? Okay. Definitely could use substitution. Anybody else thinking linear combination, elimination? That's probably what I would use. If you do not have x or y isolated by itself, I almost always go to elimination because you have in this problem a 2y and a 2y. So what could you easily do to this top equation so that those would cancel out? Multiply by -1, right? And you just have to remember to distribute. Now, that's not to say you can't do substitution because it works also. So, but if I do this, I get -1 times 2y, which is -2y. -1 times -4, which is +4, equals -1 times 0 is 0. So you effectively have changed the equation slightly, okay? Now, usually you try to line these up vertically, but I'm not going to rewrite them. You can. But right here is where you have the -2y plus the 2y. I always like to put them in rectangles and say, hey, I'm eliminating these. I'm getting rid of these. So these will cancel out, and they're both still on the left-hand side. So what do I have left? I have an x, when I add them together, plus 4 equals 0 plus 5 is 5. And you probably know what the answer should be here for x, but if I were to solve this algebraically, which is what you should do, subtract 4 from both sides, and x is equal to 1. So am I done? Is that my answer? No, you have x and y to find. So now when x is equal to 1, you need to substitute that in one of your original equations. Why do I say original? Because just in case you made a mistake up here, you could substitute it back into that new equation, but in case you made a mistake, we don't want to blame it on the mistake that you made, okay? So looking at my 2 original, I would put it back into the second one because that seems a little bit easier and smaller to handle. So substituting 1 in for x plus 2y equals 5. Now I'm trying to isolate y. What should I do to both sides? Subtract 1, subtract 1. 2y is equal to 4, divide by 2, and y is equal to 2. Should I leave my answers in that fashion? No, you should change it. Make it an ordered pair. So my final answer here is 1, 2. The ordered pair 1, 2. Excuse me. So what does this one solution tell me? What does this tell me about my lines? What kind of lines are they? They are some nice lines. Yes, they are nice lines. What kind of lines? They are intersecting lines, meaning they are going to cross each other at this particular point, which means if I plug these numbers in for X and Y, they are the only ones that will satisfy and make that equation true for the two of them. Okay? And again, this is called elimination because you're actually trying to eliminate one of the variables, or it's also called linear combination. And did you happen to get the same values? Yeah. So you can still also use substitution. All of these work. It's just a matter of, what you think looks easiest to do. Right, Miss Leah? Do you have your book with you? Could you pay attention just a little bit? Just a little. Any questions about this first system? All right, are we ready for the second one? You guys look alive and bushy-tailed. No, you don't. That was sarcasm. So number 2, 3x plus 8y equals 18. X plus 2y equals 4. Graphing would probably not be the way to go here. Then do you think linear combination elimination, or do you think substitution? And why? Okay, so a vote for elimination. What do you think? Are you agree?
Yeah.
Okay. Okay, vote, yeah. So most, yeah, elimination, I would agree. You could do substitution, but neither one of the X or Y variables is isolated. What would you do here? There's a couple of different things you could do to eliminate. Okay, you could multiply by -4, which is going to get rid of which variable? The Y. You could also do what? Multiply by -3 to get rid of the X's. So it doesn't matter. It's both going to end up the same answer, whatever is best for you. Since we said -4 first, I'm going to do that one. So -4 times X is -4X. -4 times 2y is -8y. Can you see, or am I in your way? Okay. And 4 times -4 is -16. So essentially we've gotten rid of that. Let's add these together. 3x and -4x gives me -x, 8y, and -8y. Those cancel out. And that is equal to 18 plus -16, which is +2. So if -x is equal to 2, I can divide by -1, and x is equal to -2. Substitute that back in for either one. I'm going for that second one because it has x by itself. So in my second equation, I'm saying x is -2 plus 2 times y equals 4. Any questions about how I did that or why I did that? Okay, I am solving for y. What do I have to do here mathematically first? Add 2, yes. Get rid of the 2. We were trying to isolate the y. So that gives me 2y is equal to 6. What's happening between 2 and y? Multiplying, so I need to divide. And y is equal to 3. So my answer here, as an ordered pair, yes, you should always put it in parentheses, is -2, +3. So again, what does this tell me? If I have one solution, what kind of lines are we dealing with? Linear and what else? Intersecting, yes. If you have one solution, they're going to be intersecting. Any questions on number 2? All right. Okay, let's go to problem number 3. This is the last example that we're doing. Solve by any method. 2y minus 4x equals -4. Y is equal to -2 plus 2x. Floyd, what method would you use here to solve? You are exactly right. Substitution probably would be the way to go. And why did he pick that? How do we know that? Why substitution here? We could do elimination. We could multiply by -2y, right? But you have the y isolated. So where you have one of the variables isolated, usually you want to go to substitution. Okay? So if y is -2 plus 2x, we're going to substitute that in place of the y in the other equation and say 2 times that y value, -2 plus 2x, minus 4x equals -4. And when you substitute that in place of the one variable, then you're only dealing with one variable, and you can solve for that variable. So we need to distribute. 2 times -2 is -4, and 2 times 2x is 4x, minus 4x equals -4. Ooh, what do I do here? What's going on here? Yeah, I have to add my like terms. So 4x minus 4x, that's going to simplify and be a 0. And I get -4 equals -4. Ah, yes. Is that true that -4 is equal to -4? Yes, that is true. And as Lonnie said, if you get x equals x or -4 equals -4, and that is true, that should tell you we have infinitely many solutions. Now, my question is, how do we get any solution? What would I need to do here? So, okay, I have infinitely many solutions, but does that mean -1, 3 is going to work? Not necessarily, but how could I figure out what does work with -1? I need to substitute it back in for one of these equations. So if I want to try and get one of those solutions, -1, substitute that in. I'm going to do this over here and say 2y, excuse me, minus 4 times -1 equals -4. 2y, -4 times -1 is plus 4 equals -4. I need to isolate and solve for y. Subtract 4, subtract 4. 2y is equal to -8, so y is equal to -4. So that would be the ordered pair for when x is equal to -1. And then you could substitute in for 0 and 3 and any of those values, okay? Usually you don't have to do that. Usually they just expect you to know infinitely many solutions. So what do these lines look like if they're infinitely many solutions? Yeah, one line right on top of the other, okay? One line right on top of the other. Another way you can look at this, I mean, we already have this as y equals negative 2 plus 2x. Try to solve for y here and see what you get. So let's, let me get rid of this little thing. I could say 2y minus 4x equals negative 4. Solve for y. Add 4x, add 4x. Those cancel out. 2y equals 4x minus 4. Divide by 2. And you get y equals 2x minus 2. Exact same equation as what you have here. So that's how another way you can tell they're the exact same line. One on top of the other, infinite number of solutions. Any question about that? Okay. All right. So that is the end of our notes. On page 38, if you were writing these in, you had lots of space. Your homework, this is the first homework of this topic 5, is topic 5, homework 1 on Canvas. It is actually page 39, those problems. So you can continue and just work on page 39, do the work in the book, and then put the answers on Canvas. Also page 40. Okay, so it is all very similar to what we just did, especially page 39, just more problems. So you can do your work on these pages and then enter your answers in online on Canvas. Okay. Also, just a final reminder, any and all homework from the last module 4, which the test most of you took on last Tuesday, any homework, the review is due by tomorrow. Okay? Due by tomorrow. And those of you that just entered the class, there's like 3 of you, you do not have to do any of those, but you will be responsible for that material. Okay? For the final. All right. Any questions about this at all? Hopefully that helped you a little bit with the extra practice some of you said that you needed. What kind of lines are there if there is no solution? What do we call those lines again if there is no solution? So they're not going to be intersecting. They're not going to be one on top of the other. What kind of lines do they have to be? Parallel lines. And if you get something for parallel lines, let me just write this down in case you want to watch this later. Parallel lines have no solution. Otherwise, you could also say the null set. Okay. And where was I going with this? Parallel lines, no solution. I lost it. It was something profound, I'm sure. All right. I guess not. But that is the third type of line. So parallel lines, intersecting lines, and totally lost it again. Intersecting, parallel, oh yeah, and infinitely many solutions. Parallel lines, no solution.